All right, we have a number of things to do tonight. One is go over the exam. Then the other thing is to talk about the next group project, and then the class exercise. So let's look at the two questions that required you to write programs. So I'm going to go over the implementation that I have, and I would ask you to take a look at the multiple choice part on your own, and then look at the answers and ask me if you have any questions. The average for the two parts of the exams combined is 75, which is not bad. So let me share my Eclipse window with you. All right, let me go over my implementation. Let's start with the changes to the library. You need to modify the library system so that members can be removed. That was the question. So here is, let me go ahead and open up all the relevant files first, and then show you the window. All right. Okay. Let me see if I mean, give me a second. I forgot whether I was recording or not. Yeah, I am recording. Okay. Let me first go to member list and show you the code I have for removing a member. So given a member ID, it pulls in the member object, and then if there is no such member, returns false. Otherwise, it removes the member. Some of you passed a member object to remove member. I did not take off any points for that, but I don't think it is a good idea. The reason is you want to have as much of the responsibility for locating the member, or as much of the responsibility for removing into the member list class. So it is better to pass the member ID. So think of that, and I think you should consider such issues when you implement. I know that you are under a lot of pressure when you're taking an exam, so I did not take off any points for that. Then the member class should have methods to check whether it has any holds or has checked out books. So I have two methods, has holds and has checked out books, and they look at the two corresponding lists and then sees whether the size is not equal to 0. So that is what you have for the member class. Then for the library, I have introduced two constants. One is that has placed holds. This is to indicate whether a member has already placed some holds, so that cannot be removed. This is the other error condition, that the member has checked out books. And the remove member is at the bottom here, and it searches for the member, and if there is no such member, it returns an error code. And if the member has holds, returns an error code for that. If the member has checked out books, again, the member cannot be removed, so an error code for that. And if the member could be removed, then it returns operation completed, otherwise returns operation failed. There were a few submissions where you had the business logic display messages. You should not do that. So I have taken off points for those kinds of things. That is not an appropriate way of dividing up the work. Finally, the user interface class, I have introduced the remove member 13. I know that some of you had difficulties getting this going. So if you had a remove member equal to 13, and a couple of you asked me questions about the fact that when it was 13, the program was not processing that request. Actually, that stuff is in the get command method. So there is, it verifies that the command is valid. So you had to change that. And I think that is because that is the reason why many of you had a different command number for this. I did not take off points for that. But I just wanted to show you where that was. Anyway, here is the remove member method, my code. Get the book. Actually, I forgot to change this variable. This should have been member ID, not book ID. Yeah, that was a mistake. So this should have been refactor, rename. So, and then it calls the remove member of library and then prints out messages based on the return value. Any questions? Okay. Then let me go ahead and show you the other program, my implementation. Oops. All right. This program required you to refactor the code to convert among file types. And the refactoring rule was replace conditionals with polymorphism, which many of you identified correctly, but some of you did not get the implementation quite right. So remember that, okay, maybe it's a good idea to look at the problem as well. The okay, if you look at one of those files, it has all these types. Converter from standard has 3 file types: GIF, JPEG, and PNG, and it has this convert method which looks at the destination type and then acts accordingly. So it is this kind of stuff that we discussed in relationship to the library that should not be in an object-oriented program. So these are conditionals. These are conditionals, and you should replace each leg of the conditional with a class. So for GIF, you have one class. For JPEG, you have a different class. And for PNG, you have a third class. And then the code should go into the method called convert in each of these classes. And convert should be a method in the superclass, It could be abstract. In this case, it is appropriate for it to be abstract because there is no common code. But if there is some common code, you don't want it to be abstract. You want to put the common code over there. And this is common to all file types. So this can be moved to the superclass too. So that is what I have done. In fact, converter from standard and converter to standard have similar structures. So I have a single superclass called converter, and I changed the source and destination to be protected so that they can be accessed from the subclasses. And there are no file types anymore. Some of you still had file types. You are not. Some of you are not. Didn't seem to be sure how to handle this whole thing. There are absolutely no file types. The classes are the different types now, and we have the abstract method convert here, and the converted picture is in the superclass, and the subclasses are things like GIF to standard, standard to GIF, and similar files for all the other file types. So if you introduce a new file type, what you need to do in this implementation is create 2 new classes. Any questions on that? All right, if there are no questions, let's spend a few minutes on the next group project. So let me share this. It is available on the D2L site. So I ask you to take a look at it. And there is also a video on it, but I will spend a few minutes discussing this project. Okay, the second group project is due next month, immediately after the final, December 12th. And please submit it by the due date because I need to grade all these things and submit my grades. So this requires you to design and implement a system using the finite state machine model. Without really going through all these write-ups, let me show you the last page here of the document. What you need to have is essentially a remote control for a video player. So this remote control has some familiar buttons like on, off, play, stop, pause, fast forward, and rewind. And this remote control also allows you to select a bunch of programs. So the programs are fixed. So we are not going to have a variable list here. There are only 5 programs that you can select and play. When the player starts, it is in the off. It is off, basically, just like any player. And then to do anything at all, you need to click this or press this on button. And when the on button is pressed, you can play one of these shows. So you need to select a show and then click play. As you are playing, you can pause, you can fast forward, and you can rewind. If you are paused, you can resume it by clicking play. But while you have paused, you cannot do something like fast forward or rewind. Similarly, when you are doing fast forward, you can't suddenly say, I'm going to rewind now, right? You have to stop that fast forwarding and then rewind. So those kinds of details are all given in the write-up. At any point, you can click off and the whole thing turns off. Then you have to turn it on before you can do anything. And suppose you start up this player and you don't do anything on the buttons for 10 seconds, then a screensaver comes on. Of course, you are not going to show any videos here. If you want, you can do that. But all I am expecting for the screensaver is a message that says ICS 372. Okay, that is the screensaver. And you can get out of the screensaver by pressing one of these buttons, and then you are back to the selection mode. And once the show is over, that is, you have reached the last end, I mean, or not last end, I mean, the end of the show, the player gives you 10 seconds to play it again, or you could also press stop so that the show is deselected. Okay. So there are all kinds of such details. I can't go through all of that here, but they are all given here. So read all these paragraphs here, and then also watch the video. It gives you a more visual feel for what the system does. I know you are familiar from the third programming assignment on how to create a Java FX file with buttons and a box like this. This is a text area that I have. But you are probably not familiar with this kind of a widget. This is called a list view. And to make it a little easier for you, I have provided the code for getting this on the screen. Of course, you have to take that code, copy it into your project, and then put that control inside. So I have created, I think, 3 files that, let me see if I can show you that. Give me a second. Let me go ahead and show you that file. It may take me a couple of minutes to find it. Okay, yeah. I should be able to show it to you now. All right. Those 3 files are here. One is a collection class that contains a bunch of shows, the list of shows. So I created those shows here with the names and running times given in these 2 arrays. You don't have to know anything at all about how these things work. You don't have to know anything about this collection class. Just use it blindly, right? So I just don't want you to get, I mean, I don't want you to be bogged down with the dirty details of things that you're going to forget immediately after the project is over. So I don't think it is worth it. And then there is a class called show, which you have to know a little more. A show has a name and a running time, and it's a very simple class. You can get the name of the show and the running time using getters. So this is more important. You have to know, I mean, it's so simple. I don't think there is any difficulty in understanding this. Then there is a control here. So this is what I have in that graphical user interface. So it extends a control called list view, and it connects the collection with this control. You don't have to spend a whole lot of time understanding this code. What you have to understand is that when a particular show is clicked, control comes here, and the show that is selected is in this reference show. That is the important thing you need to know, right? This is the crucial line. It is just fine if you don't know anything about these things, although you need to create an instance of this and put it in the graphical user interface code. But the most important thing here is to recognize that this reference contains the selected show, and it has a name and a running time. So what you do with the show is something you need to decide. And how do you get this control on your graphical user interface? For that, you need to use this piece of code, but it doesn't go here, all right? It goes into your the container, the stage. When you create the stage for your JavaFX program, that is where you would have some kind of a panel, and you will add this control over there. So I call this, I think, show list. The instance of select control I call show list. So this show title is going to be a name for this control. So you need to copy these two lines into your stage in the start method, and you need to have a panel to store this control. Okay, so this helps you not worry about unnecessary things. Now, the biggest chunk of time that you would be spending, I think, would be developing the state transition table and diagram. Of course, if you develop one, you get the other, right? So that is where you would be really spending time. And that doesn't require writing any Java code or anything, obviously. So initially, it may be very difficult to get a handle on that, but as you discuss, I think you will make inroads. And if you follow the approach given in the reading that I have put on the D2L site, designing with the FSM approach or whatever that document is named, you should be able to get a better handle on that stuff. And you don't have to do a whole lot of documentation for this. Let's take a look at that. What documentation you need. Going back to that document, what you need to submit are two files. One is on the analysis and design. Basically, for the analysis and design, I need only two things: the state transition table and a partial state transition diagram. The state transition diagram is going to be really cluttered if you show all the transitions. So I don't want you to be spending a whole lot of time on that. So I want you to show all the states, but only a limited number of transitions. So only transitions for a selected set of events. The state transition table should be complete, and the states and events should be correct. I don't think there is more than one way of coming up with the states and events in this problem, or not. At least there are not that many different ways of coming up with those, and they should be promoting good object-oriented design and implementation. And the project will be graded based on the correctness of states and events and the correctness of state transitions. If you make mistakes with the states and events, you will lose credit for the state transitions to some extent. And the implementation is worth 40 points. It depends upon correctness and code and documentation and how well your code is sticking to object-oriented principles. Now, the groups can be changed if you wish. So what I would ask you to do is wait until you submit your group work for the first, the documents for the first project that is due tomorrow. And after that, see whether you want to have a new group. I think for the second group project, you don't really need that much manpower because many of the artifacts that you had to submit for the first group project are missing here. You don't have to submit any sequence diagrams, no class diagrams, none of that stuff. There is a table, is the state transition table, and the state transition diagram, part of it to be submitted. And then there is the code. And speaking of code, you will find that you can borrow heavily from the implementation of the microwave, which we are doing this week. So let's take a look at that. And give me a minute to show you the relevant things there. All right, here is I'm expanding the packages, the most relevant packages for the microwave implementation. You can see there are packages like buttons and display events and so on. The application was created by Java, I mean by Eclipse. I did not create that. And there is a start too. And this package buttons contains all the buttons. The graphical user interface code is in the display package. All the events are here. There is one class for each event, and there is a superclass microwave event. Then all the states are here, plus the context and timing related stuff, the clock and the notifiable interface and the timer object, sorry, the timer class are here. You will find that or I'm not saying you will find it, it is a lot easier for you if you simply borrow this kind of a structure into your solution. So what I would suggest is create packages like this in your project. Create one file for each button, couple of files for the display, then one for each event, and then one class for each state, a super class for that, and a context class, and then these you can simply copy and use. You don't have to do anything with them, really. I just copied and used them without making any modifications. And of course, you'll have to change the names of all these buttons and the events and stuff like that. And you should probably take an approach similar to what I have done in this main.java, which starts up the whole show here. So this is what I do. This is how you begin this. You click on the main and then start that. That essentially starts the microwave. Of course, you may not have seen that graphical window there. So that is what I have to say about the second group project. So to recap, it is due immediately after the final meaning the third exam, and it requires you to analyze, design, and implement using the FSM approach. And I would heavily suggest that you understand this implementation very well and borrow as much as you need, but you must change all the class names and stuff like that, and stick to object-oriented principles at all times. And in the just to give you a little heads up, I'm thinking that in the final you will have to implement you'll have to implement part of the functionality in a FSM based application, and a similar thing for the drawing program. So I will talk about, I'll give you some more details as we go through the rest of this semester. Okay, so it is in your interest to understand this implementation very well, and the focus of the class exercise is to actually help you navigate this code. Okay, so any questions before we set up the breakout rooms? Anything at all?
I had one question, Professor. Yes. On the schedule, it says read the handouts from 9 to 11, and I couldn't find any handout on D2L.
Which handout?
From 9 to 11.
Okay, what I for these, I mean, some of it. Let me take a look. Right.
Sounds good.
Let me see what I maybe there was some of it might have been misleading. I will. Okay. Syllabus. Okay. Oh, okay. What I meant was this document, which is under content, and it is called under readings. It is called designing with the FSM approach.
Oh, okay. Thank you so much. I get it.
That is the one. Yeah.
Thank you.
Okay. Thank you. Then any other questions? Okay. Let's see if there are. Yeah. Right. The graphical user interface has to be in pure Java. Yeah. You cannot use any XML, no shortcuts. Okay. Actually, that code is going to be very short. I mean, by Java standards. Okay. By Java GUI standards. That was a question on the chat window, so I'm answering that. Then let me stop recording here, and